Hello everyone, hope you all are doing well. In today's video, we are gonna talk about time series forecasting. This is most interesting topic if you have to predict future values of a particular data set. Technique which we are gonna use here is Arima model, and the programming language we are gonna use here is Python. Before moving forward directly into the coding, let's look at the data set which we are gonna use for this tutorial. This is the data set which we are going to use for our Arima model. This is basically electricity production data from 1985 till it goes down till 2018. Yeah. Also, let's quickly draw a line graph of the same data just to have an overview how it moves towards the timeline. Okay, so if we look here, it seems like it contains both seasonality and trend. Now, let's move into the coding part. Before we directly jump into our Python coding, there are some basic assumptions which I'm moving forward with. I'm already assuming that you have a basic understanding of how Python works and some basic knowledge on how statics works, like how hypothesis testing works and all. So before further ado, let's jump into our coding part. Save time, I have already created a skeleton program, so which we are going to use once we move forward in the video. uh, so there are a couple of steps involved here in this tutorial. So first of all, it's like we load all the required libraries, then we load the required data, then we try to plot the data and see what actually our data is. Then we will try to split the data into seasonality, trend, and residual. After then, we will split the data into train and test. On top of this data, we will try to fit an Arima model, and at later stage, we will try to predict on top of this model the future values. So let's move forward. First of all, let's load all the required libraries here. Once we load it, in this step, what I'm trying to do, I'm just trying to read the production data which I have already saved in my system. So let's read it. Yeah, and using the head command on this data frame, I'm just displaying top three values, what it contains. So as I explained earlier, this data set contains two columns, the date and the production of electricity. This is the code, you can just ignore it. We will rename it in future. So this date indicates the date, or I mean it's like for this month this was the production, and for this month this was the production. It's like that. So here we are just trying to create a copy of df production from our main data frame. And once we created the copy from our main data frame, in this step what we are trying to do, actually the data which we have read, it has two columns, date and production. This date column needs to be converted into date type. For this we are gonna use pandas datetime function here. This is where I'm doing it. So you just run it and it gets converted it into proper date type. Again, I'm just trying to display the top three records using head function. So head function works is like whatever value you supply it here, it will display those many columns. If I want top five columns, I'll just pass five and I will run it. So it will display me top five columns here. Again, once we convert our date column to a proper date type, next step is to we set the index of our data frame to date column. For example, the same thing which we are doing here is like df production dot index would be the date column of our data frame. And once we run it, let's try to using head function, let's try to again see what it contains. This is how it is, dot head 3. Yeah. So now if you see here in index, I have date, as in earlier it was the index 0123, but now in index I have date. Now next step would be to plot the data. By plotting the data, what I mean, whatever we have loaded into our system, let's plot and see what actually it represents actually. So let's let's try to run it. Yeah, this is our data. Yeah, this is the graph of our data. Now if you see closely, over a period of time from 1984 to 2016, it looks like data is overall moving upward as in trend, and looks like it has also some seasonality factor in it. It's like moving up and down, up and down, up and down. So to go into more precise detail of our data, uh, we will try to split data into three factors. The one is the trend of the data, then the seasonality of the data, and then the residuals of the data. How we are gonna do it is the next what we are gonna do. So yeah, here it is. We will, in this section we will split the data into three different factors: trend, seasonality, and residual. To do this, we will use seasonal decompose function available from the package itself, and we are gonna use additive model here. uh, Basically we have two types of model available: additive and multiplicative. In later stage of the video I will try to explain when we use additive and when we use multiplicative. Yeah, once I run it, here is our, so this is our actual data. And if you see, this is the trend of our data. This line represents trend of our data. What is the trend of our data? And this is the seasonal factor of our data. It looks like our data has both trend and seasonal factor in it. And this is a residual factor of our data. If we will split our data into these three parts, this is how it will become. So to understand it, you can think of it like that: if I sum all of these three, trend, seasonal, and residue, it will make this our original data. After we have seen that our data contains seasonality, trend, and residual, in next step we will figure out whether our data is stationary or not. This step is very crucial because Arima model can be applied only on a stationary data. So to test whether data is stationary or not, we will use AD Fuller test. So, as it states that we will be using AD Fuller function available from the package itself. In AD Fuller test, null hypothesis states that data is non-stationary, and of course the alternate hypothesis will be that data is stationary. So if we run our AD Fuller test on top of this data, our p-value is 0.18. So of course it's clearly states that 0.18 is greater than 0.05. So our p-value is greater than the threshold value, which is 0.05. So in hypothesis testing, alpha value is directly considered to be as 0.05. And since the p-value is greater than the threshold, so we will accept the null hypothesis, which means our data is non-stationary. Now since our data is non-stationary, when we are applying Arima on top of it, we will have to make it a stationary, because Arima model can work only on a stationary dataset. In next step, uh, we have to split the data into train and test, so that we can train on a particular set of data, and then we can test how our model is performing on the test data. This is where we are doing it. So we will test, train and test. Again, we will try to plot our split data. This is how it is coming. The green represents our training data, and this blue one represents our testing data. So on top of this data, we will be applying our Arima model, and on top of blue line, I mean blue line represents of course a piece of data. On that piece of data, we will be applying our Arima model to see how it is performing. Now, before moving forward, there are certain concepts about Arima model which we need to understand. After splitting our data into training and testing, subset, we have reached a stage where we will have to apply our Arima model. So before applying Arima model, there are certain factors which we need to figure out. Those are P, D, and Q values. To understand it deeper, we this is how we move forward. P is the autoregressive term from our Arima, as Arima suggests that its full form is autoregressive integrated moving average. So each term in this Arima full form basically is self-explanatory. So P is the order of autoregressive, D is the order of integration, and Q is the order of moving average. So autoregressive, you can understand it like that. It's a relation between observed values and number of lagged earlier values. To be more precise, or in layman terms, it's like correlation with the past values. It is what is considered to be as p-value. And D is the differencing raw observation. And Q is the moving average. So it's like you can think of size of moving average window. It goes through the data. Now, to find out these P, D, and Q values, there are multiple ways to do it. The visual way is PACF and ACF plots, as I have mentioned it here. So these are the visual ways, PACF and ACF plot. But frankly speaking, I find it really difficult to find P and Q order from PACF and ACF graphs. There is also auto Arima model which is available in the package itself. But I'm gonna show you a different approach through which you can mitigate the error and you will get a proper PDQ value. Uh, Also, before we move forward, uh, if on a data set we have to apply Arima model, there are certain assumptions which we make. The data should be a stationary. Of course, just now we did a AD Fuller test on top of a data and we realized that our data is non-stationary. So this is really funny because in real time scenario, whatever the data we will get, it is never a stationary actually. So we will have to make it a stationary somehow. And there are no outliers or very less outliers. And this is an ideal condition for our data set to be used for Arima. But in reality, this never occurs. So let's deal with reality. Now, coming to our coding part once again. In this section, I'm using auto Arima to find P, Q, and D orders for our Arima model. So auto Arima is the function already available from PD Arima package. What it does is basically like that. For PD and Q values, you supply maximum value and minimum value from where it has to start, and it will run through all the possible combinations and it will try to give you best possible PDQ values. Let's try to run it and see what it gives to us. Performing our Arima. Yes, here it is. So best combination of PDQ is 0, 1, and 6. We will try to train our Arima model with this order, but let's try one more approach to find PDQ values, and we will try to compare both values, how it performs on our data. So on a different approach, what we will do, I have put PD and Q from a range from 0 to 6, 0 to 6, and 0 to 2. For D, I am taking 0 to 2 because in differencing we hardly go beyond 2. Um, till date, whatever data set I have ran through, it hardly goes beyond 2. So that's the maximum. You can put it to 3 or 4 also, but I don't think it's of any use. It will be just waste of your computational power of your system. Again, using iterative tool, I have created a list of all possible combinations. So as it states said, there are 72 possible combinations of P, D, and Q. In this section, what to do is I have created two arrays of Arima order and root mean square error. And in this loop, here I am passing the data, and for every value in that uh, list which we created earlier, that's the order which I'm passing here. So it's like this trained model will calculate predicted value. This here it will predict predicted value This trend model will create predicted value for every possible values which we have created in our list. We'll try to append error as well as the order to the array, and we will use that array to convert it into a data frame, which we are doing it here. Oh, it's an error. Let me run it first. Oh, I didn't run it earlier. It will take some time to run because it's set high on computation. Let's wait for 1 minute. After converting Arima order and RMAC to our data frame in this line here, and then after converting to data frame, I am trying to sort the values based on error. So idea here is that I am trying to arrange the data set based on the least error on the top of it, so that we select those values, those PDQ values where the error is really less. That's what I'm doing here. Once I display it, I realize that 305 is giving me less error, which is 3.13. 304 is giving me 3.186. There is not much difference, but uh, I mean, for the sake of convenience, let's take 305. But the catch here is that our earlier Arima auto Arima has given us 016 value. There is so much difference between these two. That's what I was trying to explain. Okay, so let's try to put these values in our model. So to train the model, this is what we are gonna do. Model fit Arima train. Then we are supplying order here 305, and I'm fitting on top of it. Just try to fit the model. Yeah, our model is ready. It just take hardly microsecond. Now this step is really important. Till now whatever we have done is like we have uh, mm, created our model, and next step is to, on top of this model, we will use this to predict our future values. As earlier we have seen that we have split our data into train and test data. So we train this model on our training data, and now we are going to predict future values, and we will compare those future values with our test data. So this is what we are trying to do here. In prediction, I am trying to predict from 300 to 396 values. In this section, I'm just trying to how do I put it, I'm just trying to convert the data into data frame so that I can plot it. Let's plot it. For plotting, I'm using matlab library from Python itself. uh, and you see here, this the green data is what our I mean training data set is, and what our actual data set is, and this orange one is what is getting predicted. Right now it only represents the training and predicted dataset. Now if we have to compare it how it is behaving with our actual test dataset, we will try to plot one more graph here. This is where it is. So this blue one is the actual test dataset, and the green and the orange one represents our new predicted values. Looks good, isn't it? Let's try to plot only test and predicted values. Let's see how it is. Yeah, looks okay to me. I mean, there are couple of hiccups here and there, but it looks like it's following our data patterns completely. Finally, I hope you are happy with this video. Just to recap, we learned on how we can use Arima model to predict future values on top of a data. Next step on this would be to use Sarima on the same dataset. Right now we have only captured the trend value of a data. If we want to capture the seasonality value as well, we will be use Sarima on top of it. We will be following same steps for Sarima as well. Only the extra step would be to introduce the seasonality factor. and plotting, loading, and finding PDQ value will all remain almost the same. So see you in next video.